Okay, so this is another computer science video, and today we're going to be doing 2.2.1 and we're going to be covering programming constructs. So this is a brief overview of the topic. So we have 3 programming constructs. You also have recursion, but that is a separate video, and I'm going to explain the 3 here. We have sequence, which is when code is executed line by line from the top to the bottom. And sequence is important because obviously sometimes in your code the order or sequence of the lines matter, and a different sequence could really affect the result and the logic. Okay, and then we have branching, which we can also call selection. You can use them interchangeably. And this is when a particular section of code is run only if a specific condition is met, so it uses if and else statements. And iteration, so you have 2 types. You have count controlled. This is when a section of code is executed a certain number of times. And you have condition controlled, where a section of code is executed while a condition is met. So it uses for, while and do until loops. For, well, we can say that would be count controlled, as you can do for example, 0 to 10, right? That's count controlled. And then for condition control, you can use while or do until, because obviously with while, for example, it is a section of code is executed while a condition is met, and if that condition is not met, then that section of code won't run. Identify the construct used on lines 1 to 3 in the algorithm. Okay, so the pseudocode algorithm is shown. It contains various errors. Okay, so the construct used on lines 1 to 3, so we need to look at this section. So 0, 1, total equals 1, smallest equals 9,999, and largest equals -1. Well, there's no for loop here, there's no while loop here, and there's no do until loop here. There's no if loop here either, so we can say that this would be a sequence, and that matters because it's telling us the variables before it does everything else. So you would say a sequence. Okay, now identify the construct used on lines 10 to 12 in the algorithm. So lines 10 to 12 is here. If data array X is less than smallest, then smallest equals data array X, and if. Immediately, it uses an if statement, so we know that would just be branching or selection. Okay. Rahel owns 10 different function rooms which can be hired by different business customers to hold meetings. He would like a program to manage the booking process of each room. Customers should be able to enter the date they want to hire a function room, and then a list of available rooms will be displayed. Customers can then select which room they would hire. Customers can enter their payment details, which are then checked, and then a confirmation email is sent to the customer. State 2 different programming constructs and give an example of how Rahel could use each construct when creating his program code. Okay, so we've been given quite a lot of information, and we need to find 2 out of the 3 programming constructs which you could use. So when I thought of this question, my mind immediately went to this part here, which is where the customers can select a room and then they enter their payment details. So this can be a sequence, right? Because the payment details can't be displayed until they've selected their room. So that is your first one, sequence. And your second one could be branching. So if the payment details are successful, then a confirmation email is sent to the customer, and that is said here, right? Okay, question 3. One creates a function, count row, to count the number of coloured boxes in one row and return the number of consecutive colour boxes in that row. If there is more than one set of coloured boxes in the row, these are joined together and the string is returned. For example, in the following grid count row, for row 0 will return 2 as a string, and count row for row 2 will return 1, 1 as a string. If there are no 1s in the row, then 0 is returned as a string. Complete the pseudocode algorithm count row. Okay, so this question has given us this code here, and what we need to do is we just need to fill in these blanks. Okay, so our code starts with the function count row taking the parameters puzzle by ref, puzzle being this grid here, and row num by val. It sets the count as equal to 0 and the input being set as a variable, and then it says for I equals 0 to blank. If puzzle row num I equals, then count equals count plus 1. Okay, so first, for this section that we're going to complete here, well, we know that this is our grid here, and it's basically iterating or going through each sort of number in the row, right? And we know that in computer science, numbers are usually indexed and starting from 0. So this would obviously start for I equals 0, and we have this here, which is 0, this is 1, this is 2, this is 3, and this is 4. So we'd say for I equals 0 to 4. If puzzle row num I equals, then count equals count plus 1. Okay, so when does count increase? Count increases when we find the coloured box, right? And what is a coloured box represented by? 1. Okay, now we can move on to the next part. Else if count is greater than or equal to 1, then output equals output plus string blank plus space. Okay, so like I said in the question, this is basically just a result that it will return, and this is basically once it's finished counting its group of ones, right, and it's going to add this to this part here. So we just literally put the count which we've been adding to in this part here. Next, we're going to move on to this part, this if statement. If count is greater than or equal to 1, then output equals output plus string count. Else if output equals, then output equals blank. End if. So this is basically when no runs of ones are found, and you just simply put that as 0. And then end if, return, and then what are we going to ultimately return? Or output, right? And that will be the result from either this or from this. Explain the purpose of line 3 in the function count row. Okay, this is our completed code here. We've got line 3, which is output. So it initializes the variable output with a space. So basically, it's just setting this variable, but obviously it doesn't have a value yet because it's going to change throughout the program's duration. Yeah, so it can be used later in the code as well. And describe the purpose of branching and iteration in the function count row. Well, we've seen that quite a lot. This is your answer here. Let me just talk through it. So checks the value stored in each index. So that would be the for loop, because it's going for, so for I equals 1 to 4, or 0 to 4, sorry, it's going through each of them. And then to check whether it's the end of each row, again, that's your for loop, and to check whether each row has been given an output or not. A recursive function GCD is given in pseudocode. The function uses branching. Identify the type of branching statement used in the function. Okay, well, this is a really, really easy one. What question? The type of branching statement, well, the only one we really know is if, and isn't if here, right? So, yeah, your answer is if. And then explain the difference between branching and iteration. Okay, so branching decides which code is run, whereas iteration repeatedly runs code in the same sequence. Okay, next question, question 5. Rewrite the function so it uses iteration instead of recursion. This is your recursive function here, which is calculate. And let's just look at the purpose of the function first, because otherwise we won't be able to actually code the actual solution, right? So function calculate num1 and num2, so it's taking these two numbers as your parameters in the function. If num1 equals num2, then return at num1. So it's basically saying if they equal, return the number, right? Else if num1 is less than num2, so if num1 is less than num2, so say this is 3 and this is 5, return, calculate, and then num1, comma, num2 minus num1, so for example 5 minus 3 is 2. Else, return, calculate, num2, num1 minus num2. End if, end function. So we can see what this code is doing now, right? We can see that it's taking two numbers and it is subtracting the smaller number from the larger number based on whichever one is bigger, right? Okay, so the first line stays the same, function calculate num1, num2. Obviously this video is not about recursion, but we know the difference between recursion and iteration is recursion has a base case and calls itself, whereas iteration will use something like a for loop or a while loop. So while num does not equal num2, which is represented by an exclamation mark and it equals, if num1 is less than num2, so the same kind of logic here, then num2 equals num2 minus num1, else temp equals num1 minus num2, num1 equals num2, and num2 equals temp, end if. So basically what we've done here is, obviously if this number is less than this number, then it will just do second number minus first number, and vice versa if it's the other way around. An end function, of course. Okay, question 6. Programming languages consist of 3 basic programming constructs, which we've talked about earlier. For each construct, state its name and give a working example. Let's start with branching. Our example is, for example, you could pick any example by the way, but Just remember for each of them which the different types of the statements that kind of go with it. So for example, with branching and selection, you have the if statement. So if age is greater than 17, print you're an adult. Quite simple, you only need like a line or two. It doesn't need to be a whole page full of code. Okay, and construct 2, oh yeah, and if. Construct 2, iteration. We can do for count equals 1 to 10. Print count, by the way, this doesn't have to be the most accurate. And then next count. And the sequence, num equals input, total equals num multiplied by price. So we can't do it the other way around, right? Because you can't calculate the total without getting the number first. And that is it. I hope that this video has been useful. Thank you for watching.